The topic of today's class is systematic debugging. Sometimes you have no choice but to debug. We talked about avoiding debugging in an earlier class. But when you have a bug, and it's found only when you plug the whole system together or when a user reports it after the system is deployed, then you have to find where it is. And for those situations, we have a systematic strategy that can make debugging more effective. The first step is reproducing it. That means making sure that you can actually see the same bug that your user has reported. And in fact, it's best if you can reproduce it with a small and repeatable test case. Now, if you found the bug by regression testing, then you already have that test case. That's the failing test case in your test suite. If it was instead reported by a user, it may take some effort first to get the same behavior, the same bad behavior that the user is seeing. And in fact, with some situations, like graphical user interfaces or multi-threaded programs, it may actually be hard to reproduce it consistently if it depends on timing of events, precisely when you click the button, or if it depends on how threads interleave. But any effort you can make in making that test case small and repeatable, that is, always fail every time you run it, will pay off, because you'll probably have to run that test case over and over while you search for the bug and try to fix it. And once you've successfully fixed the bug, then this small repeatable test case will make a great regression test that you'll just put in your test suite that will find that bug if it ever crops up again. So once you have a test case for the bug, then your goal is simply to make that test work, to make it turn green, and that's very satisfying. So here's an example. So suppose you have this function. It's supposed to find the most common word in a string, so it takes a string as an input. And the precondition on that string is that it contains 0 more words, where a word is a string of alphanumeric characters that's bounded by non-alphanumeric characters. And this function is supposed to return, as a postcondition, a word that occurs maximally often in the text, ignoring alphabetic case. In other words, we're going to treat uppercase and lowercase as the same when we're comparing words. So now suppose a user takes the entire text of Shakespeare's plays and concatenates that into a string and passes it into your method, and discovers that instead of returning a predictably common English word, the and are some of the most common words in the English language, so we would expect them to occur very frequently. In Shakespeare, we instead get something that isn't even a word, like E. Now this is an enormous input. It's about 100,000 lines of text, 800,000 words total. This input's going to be very difficult to debug by normal methods. If we put print statements inside the body of this function, we'd have hundreds of thousands of print statements as it was chewing through that string. Or if we put breakpoints in here, we would be hitting those breakpoints hundreds of thousands of times. So debugging will be much easier if we instead reduce the size of this input to something manageable that still exhibits the same or a very similar bug. Here are some strategies you can use for that reduction. One, you can cut the input in half. Does the first half of Shakespeare show the same bug? It's a form of binary search, which is always a good technique in computer science, and we're going to talk more about it later on in this reading. What if you use just a single play? There's a couple dozen plays. What if you pick just a single play and see whether it exhibits the same bug? What if you pick just a single speech, just a few lines from a play? Does that have the same bug? So we can reduce the input until we get a small test case, and then we'll have more luck using techniques like print debugging and breakpoint debugging. Then we fix the bug using that small test case, but then we still want to go back to the original buggy input, to the 100,000 lines, 800,000 words, and confirm that it actually fixes it for that input as well.